Hi, everyone. Once again, we are still on a cross-platform track for the mobile optimize, and I'm really glad and honored to welcome our last but not least speaker, Thomas Burkhart. So, hi, Thomas.
Hi.
Yeah, Thomas is working in the industry for pretty long time, like more than 30 years. And I actually have a question to you, Thomas, about that. So you have such a long experience. So how the work in this industry changed for years? And maybe something, was there an event which changed the way you do the work dramatically?
Ooh. Okay, obviously the biggest change was that suddenly there was the internet. This was
okay.
really a big change, yeah. And now, and especially that we the advance of more and more web-based application was really something new. On the other side, I have honestly to say that if you look often with new concepts, if you look deeper into it, you'll find it's not so different than what we have did 10 years ago, yeah? Another naming, another framework, it might be a little more comfortable to do, but the basic principles, I think, haven't changed so much.
Okay, I see. Thanks. So, guys who are listening to us online, we are going to have questions as usual, but for this talk, please prepare questions in advance, and maybe we'll have one stop in the middle of talk just to make sure that all the principal questions are answered and we have the good and general understanding between us, okay? And one more thing, we will have the really small competition for the best question. And the author of the best question selected by Thomas in the end of the talk will get a free book from Manning Publications about the Flutter. So I really motivate you to think about questions, and we will see who will come up with the best one. And right now, I guess we can start and talk a little bit about the Flutter. Thomas, the stage is yours.
Okay, great. Just one word to me. I'm Thomas Burkhart. I'm living in Germany. I'm a freelancer and work quite a lot in the Flutter package ecosystem as open source. So, and today I want to introduce you to my understanding how a Flutter app should be architected, how it should be structured. And I call this RVMS. We will see why. Yeah, probably you will ask why not architecture. The reason is that things we had used to before, like MVVM or MVP, they don't really fit well with the reactive architecture of Flutter because we don't have a markup layer for the UI and some automatic binding. It does not really fit. And a lot of the current state management solutions, they address only a small part what you need to build a whole app. So MVU describes the Flutter way how the UI updates quite well. But yeah, it does not, if I tell you Flutter's MVU, it does not really help you how should I build my app. And that's the reason why I think we need some more guidance. And people may have read the term RxVMS. That's what I called it the last 2 years. The reason why the X got dropped is because with RxVMS, everything was based on streams, and in the last year, this year, I worked on changing this. That we don't need streams anymore. Everything is based on value listenables or value notifiers. So that makes the usage much easier and even faster. So, what are my goals with this architecture? One really important thing for me is that apps need to be easy to read and understand and to explore if I get into a new code base. And other architectures, for example, Redux is a very bad example, is almost not to explore if you don't know what's going on, because everything is hidden with interfaces, and you can't even use the go-to definition from the UI layer to where the action happens. So, and it's a general truth in software development that you read much more code than you write it, and that it is that you often have to come back to code that you had written half a year before, and sometimes you don't understand what you thought about it. So reading and understanding is crucial if you want to have a maintainable code base. So then the second point was I did not want any configuration by convention, because just because some naming that then things are configured and set up automatically, that's it obviously violates the point one. That's the reason why I said no. That's no go. And also the framework, it shouldn't be a framework where too much is done completely automatic, where you don't see what happens. For example, I had in the past the experience that with the in Xamarin was this with XAML and MVVM, that the automatic binding was a completely black box, and it was extremely frustrating often to fix bugs. Then the other thing is I want to encourage that everyone in the team has the feeling he has ownership on parts of the whole app. We want to, this is more or less standard, we want clear separation, easy to test, it should scale. And I wanted to eliminate as much as possible minimal boring boilerplate code, as we have a lot, for example, in Redux, and also we have a lot in Block. And it should be flexible, should be fun, and I say highly reactive, because that's my understanding how you use Flutter optimal. What do I mean with highly reactive? Actually, something like this. So the idea is that the user triggers something, or an event from the outside comes in, and then your UI automatically reacts on it without listening the whole time for some state change. So this is the general structure. We have views, managers, and services, domain objects, and some helper objects. We will look now a little bit closer on it. I will go through this theory a little bit quicker, so that we have more time in the source code and for questions. Services. It's the lowest layer. They actually only they're the boundary to the outside world. So things like REST APIs, databases, or services, and all they do is they translate from this outside world into the app. So, for example, they can convert some data, deserialize JSON, and but they don't change anything in the app state itself. Yeah, the app doesn't change, and also each service typically is has a very narrow area where it should where it focuses on. The layer above, we are at the managers. So managers for me is the area where the actually business logic happens, where state changes happens, and there are often people ask me, are they like view models? No, not really, because a view model typically is only responsible for one view or one screen, and managers, they have more responsibility, and they are also longer lived than a view model in other frameworks. So the idea is we wrap everything that belongs together semantically into one object, so that we don't need to connect to a lot of other objects when we, for example, if we do user management authentication, that we can do this inside one object. So typically, if we have a database in the backend, we find some CRUD functionality there, and to do this, actually, because they are only logic, to do their job, they use services or other managers. So a manager will never directly make a REST call, for example. He will always use a service in between. And the connection to the view, we use commands and value listenables. And the idea there is, and as always, we know we need to access services and managers from the UI and services from managers and managers from managers. We use a service locator. Okay. Views, in my understanding, they can be just a complex custom widget. It can be a full page, and my philosophy is they should be, I call them self-responsible. That means that a page in general knows what it's doing and where it gets the data from. So it's not that the manager pushes the data inside the view, but the other way around, the view knows which managers it has to query. And then on the other side, we use commands to change this, change the data inside the managers. And important here, views don't modify state or data by using services. They only access managers when they modify data. It's allowed to read directly from a service. For example, if a service provides me the current compass bearing, it doesn't make sense to add another manager layer in between that will just forward the compass bearing, for example. But changing data always through managers. Okay. Domain objects, everyone knows what, in principle, a domain object is. The only interesting thing is, if they have methods, they only change their own internal state. They don't change other objects. And on aggregators, I understand if we have several objects that we want to pass as one to the UI, for example, through a value notifier or a stream, then aggregators helps us to bundle them into one entity that we can pass over. The same adapters are just the classes that allow to access data in another form than it's originally. But in Flutter, very often we can do the conversion directly in the UI. So this is a diagram where you can see a little bit more how the layers work together. We have the view layer, we have database services, and we see, okay, views use commands to access the managers and get back the value over value listenables. The manager communicates with the services with function calls or streams. Some building blocks. I told you we need a service locator. This here is called GetIt. It's one of my packages. So it's quite straightforward. You register your object, with ideally with some abstract parent class, app model, and app model implementation here, for example. And then instead of accessing something of context, we do it like this. So what you realize, there is no build context involved in these situations, which means we can use this thing. We can use GetIt not only inside the widget tree, but anywhere in our app. And to make things even easier, because this is in the past we only GetIt only served objects, but now there's also a mixin. It's called GetIt mixin that allows us to let changes in the objects inside GetIt trigger an UI update. So it gets a full state management solution already. And this looks like in this example here, it's a mixin on stateless widget. And for example, you can use watchX. WatchX observes an object that implements value listenable. And for example, I have the model class, and I have an inside a property name. And then now if I say watchX model x.name, I get on the first build, I get the value or name. And if name changes inside the model by any because of any reason, this will trigger a rebuild of the stateless widget. So this makes it very straightforward how we can access our anything that has a value listenable or other interface. For example, we can watch a stream in the same way, but we don't need any builders because it's much easier to read if I have it like this than if I have a stream builder inside. And normally, if you would want to do something like this, you probably would need a stateful widget. You don't need it with the GetIt mixin. Here you see it even better. It has register handler functions where you can register a handler, for example, to show dialog when the data changes, or if a stream emits a value or a future emits a future completes. And the nice thing is you don't need a stateful widget, and it completely automatically disposes anything that you need if you register such a handler afterwards. So this is the more important area. It's a command. The package is called Flutter Command, and it looks a little bit complex here, but it's not that difficult. A command wraps any function, async or synchronous, and you execute this function by calling the command. Yeah, and at the same time, a command implements value listenable, so it behaves like a value notifier. So all data, all results of the function are published on this value notifier interface of the command. And additionally to this, it has some more value notifiers properties. It has, for example, the is executing property. This will automatically update true and false when while the function inside here is running. And we have thrown exceptions. Any exception that happened inside here won't crash your app. No, it will get published on the thrown exceptions value notifier. And also we have a notifier that shows us if the current command can be executed at the moment. For example, to enable disable buttons. And we can pass in another value notifier that allows us from the outside to control if this command can be executed at the moment or not. And I have a little animation that makes it, that I hope it helps a little bit. The idea is the update button will be pressed, and in the end, the result data should be here. And the command itself wraps an async call to the REST service that we have. So the button press executes the command. Well, wait. Now we see here from is executing, we get a true over here, and can execute emits a false. So it's disabled and this here runs. Now data comes back. The data itself is passed, as well as a false and a true, and this updates again. Okay. Let's see some code that we have a little bit more on getting better feeling for what we are doing here. What I have here is a very simple demo application. It's it queries weather REST API and displays the result here. It has an update button that updates the things. We can up here we can insert we can set a filter, for example. Yeah, and if you see, it doesn't update immediately. It tries it after I stop. Yeah, so to not to query the endpoint too often. So this is one thing that we want to reach. And also we have this is not an UI that makes sense, but just to show you the point. For example, I can lock this the update button, and so that it's no longer possible. And if I disable it, and at the same time, but and at the same time, the if I press update, also this button enables disables. Oh, why? I just see a question coming in. Why is the response of the can execute on the button false? No, the thing is that the moment the moment the command is executing itself emits a false to signal, oh, I'm no longer executable. Yeah, so that. And at the moment that it can execute again, it executes a false, a true, and is executing, which signals me busy, does exactly the opposite. Now, you might ask, why do I need this too? The thing is executing only depends on if the function is running. Can executing depends on two things. One is the function at the moment executing, but also on the input can execute that I can pass into the command. For example, if I do this here, so now my command that is connected to this button got from outside false. So can execute is a combination of is executing and the input. Okay, so let's see how this is implemented. Oh, we get tough on time. Okay. Okay, so I get really fast here. Here we register a weather manager and a weather service, as we have. The weather service is just a class with an update that returns a future with a list of entries. I won't go into this here because this is not interesting in to the topic. And the weather manager is much more interesting because we create 3 commands up here. We create an update weather command. This is the one that will be connected to the button. We create a set execution state command. This is connected to the switch, and a text change command that will be connected to the text field up here. So typically we create these commands inside the constructor of the of a manager, and set execution command is pretty easy. It's very simple because it only forwards the value of the button. But as the command itself is value listenable, it at the same time holds this value because we have the value property inside a change notifier. So what we do is here we just pass the bool value through that it is stored inside the command. Then the update weather command. This is an asynchronous command, so we use create async. We have to pass in which is the input parameter, what parameter goes out, and what it does here, we access over GetIt our weather service, call the update method, and we have this the restriction input of the command. Oh, I have not updated this on the slide before. It's now called restrictions, the input, to make it easier distinguishable. It's distinguishable from the can execute. So what we pass into the restrictions is directly the set execution state command, because this is a value notifier bool at the same time. That's all we have to do to connect these two together, that this logic is already implemented. The text change command does, on the first look, also doesn't do much, because it just forwards the data that comes in. But what we do is here we use a function from my package functional listenables, which actually offers RX start-like functions for value notifiers. So I can directly say here debounce, because we want to have that it only updates after I paused a second or half a second, and then we add listen. Listen does actually add notification handler, but in a way that you get directly the latest value. Yeah, it's the way you normally wanted to use a value listenable, and only if debounce was let the event through, we execute the update weather command. And at least we have the update weather command thrown exceptions. We listen to them and we make a debug output, but we will see something else what we do with this. And for the very beginning, we call execute once. Oh, I'm already in the Q&A. I see.
I think we can continue for a while until we have some more questions, and you will come up with a conclusion. Okay.
Okay. So then now look. Let's have a look how this looks in the UI. First thing, without the mixing, we would have to use a stateful widget. And for example, here we would do a subscription to listen to the thrown exceptions for errors, and we would have to cancel and everything like this. But we use the mixin, and what we do here is we just do a register handler, pass in the update weather command thrown exceptions, and if the value is not null, because on every beginning of a command we reset the value of thrown exceptions to null, we show an error dialog, for example. And then we have with watchX, we observe the is executing property of the update weather command, and if this changes, this stateless widget will automatically rebuild and get the latest value in is running. Then the same thing we observe the can execute property, because we want to use this to change the button, and the switch value we also observe with watchX. And then it's very straightforward. We have the list view. We have we check is running, and depending on is running, we show either the progress indicator, or we show the a progress indicator on top of the list view if is running is true. That's the correct one to say. So, and we have up here we have the text field, and on change we can directly pass in the text change command. How do you think what implements more hard, reactive architecture at native programming or with Flutter? Oh, I think with native you now mean native Android or native native iOS. Actually, with the new Jetpack Compose, for example, or the what's the new framework on Swift? I just forgot the name. You get almost the same reactive patterns that we use in Flutter. So now today it's not really that much a difference. The only thing is with Flutter you have only to write it once, and it runs on several platforms. So, yeah, exactly. And here we see we have the raise button, and the onPressed handler we make dependent from our local variable that we got from watchX, and either assign it the command or null. And the switch, we on change we directly pass also here directly the command as handler. This is possible because commands are callable classes, so we don't have to call the execute function. We can directly use the command directly as if it were a function. And the list view also is pretty simple. It has it only doesn't watchX on the update weather command itself, where the result data will be published, and assigns this to a data variable, and and we can just use the data variable from there. No stream builder or anything like this. Just use watchX, and it will automatically update. Yeah. I think that was the overview. I would have 2 more slides, but I would prefer we go on questions if there are some.
Okay, I guess you answered both. but I have one question from my side. So you mentioned a couple of times in your slides the thing like listenable. Is it something like observable in other approaches or something different?
Is it what is it?
Is it something similar to observable in observable pattern, or is it something different?
No. Okay, sorry. Yeah, in a way, but not really, because it works different. It works a little bit differently. Actually, value listenable implements an interface that that has a value property and a function notify and a function notify handlers and register handler. So what you can do with this is that you register a handler to a listenable, and as soon as the value changes, it will automatically call the registered handlers.
Mm-hmm.
Yeah, and what I did, what I did in the with my functional listener package is that I added some functions, like instead of instead of register handler, you can just call listen or debounce. I also have combine latest things that we normally use know from our Rx. The main difference is value listenables are synchronous. So are synchronous, not asynchronous. So it immediately is executed if you push new value. Okay.
Yeah, we have another question. So
yeah, I see.
Okay. About commands cancellation.
Yeah. Okay. We have one principal problem here. We can't cancel, for example, a future. It's just not designed in. It's not. Dart does not support this in this way. So the only thing we can do is we can ignore the future, for example, and the mixin, for example, supports this in a way that if I go here, for example, I register handler, you pass over a function that gets here a third parameter, and this is the dispose function. So if you want to stop listening to this to this command, the handler itself can dispose itself, or you can or you can manually remove your command. And otherwise, for example, if I do a naturally, I can do, for example, start listening manually on a stream, for example, then I get a stream subscription back. But the idea here is that is the typical application that my UI wants to listen, and I don't want to care about disposing something, initializing something. This is done automatically. But if you want, you can do it manually.
Okay.
Any more questions?
Yes, thank you for your answer. Guys, we have 1 or 2 minutes more. So if you will come up with one more question, we still have time for that. And maybe I will just add a really small one.
Yeah.
So the whole this reactive architecture. So do you see any limitations, like any applications would be okay with it, or some applications would be not a great fit for this kind of architecture?
Actually, I think only one application doesn't really fit if you want to play write a game with because there are other packages that implement a simple game engine, for example. Otherwise, I don't really see that you will run into a problem.
Okay.
Yep.
Yeah, that's cool. Thanks a lot. So we are running out of time, so let's select one of the three authors of questions. So who will get the book from your perspective?
I would say the last one is the most interesting, because it's really something people rarely think about. Because honestly, who cares if there's some open REST call? Yeah, but sometimes you need to do it.
Okay,
that's true.
Okay, that's cool. So Andrei Tomarinson will get the book from Mining Publications, book called Flutter in Action, and I guess organizers will come up to you to let you know details. So again, yeah, thanks a lot, Thomas, for the nice and interesting talk, and for this insight to the reactive architecture with Flutter. So it's also possible. It has a lot of benefits. You just need to get into it, and so just enjoy writing a good application. So thanks a lot. And dear audience, you are welcome to join our special chat, as you, Thomas, as well. So if you will have more questions or some insights you want to share, so please just go there. The link is somewhere in your emails, and just have fun hanging out with other speakers and other conference members. So thanks a lot. It was a really good time here with a cross-platform talk, and hope see you somewhere in another conference.
Thank you. Thanks a lot. Yeah, I also enjoyed it. Thanks.
Yeah. Thank you, Thomas. Thank you, guys. Bye. Don't forget about the special chat. Okay.